Hello. So we're going through the sample exam. We did question A and B. So let's do question C. So question C says, Avital, so he's another person, also lived in Orange Beach in 2015, but was not involved in the drug business. So unlike Aristeo, who was a person involved in the drug business, Avital was not involved in the drug business. How probable is it that Avital is the victim of a violent crime? Who is more at the risk of being a crime victim, Avital or Aristeo? Okay, so you should feel free to pause and think about the solution by yourself. But let me pull up the solution here. 1 second, sorry. Okay. So I'll put C up here. And then here's the solution. So this is C. So what we want to know in this case is the probability that Avital is the victim of a violent crime. And what we know, the only information we know about Avital is that she is not involved in the drug business. So bottom line, the probability we want to know is a conditional probability. Is the probability that crime victim conditional on the complement of drug. Right? Remember that the operation of complement picks out all the elements that are not in the said drug. And this is appropriate in our case because the condition that we are considering is not being involved in the drug business. Avital is not involved in the drug business. That's all we know about her. So the condition we want to consider is precisely complement drug, which means the event of not being involved in the drug business. Okay, so this is a conditional probability, so everything is just like before. The only new thing here, and that you shouldn't be confused, the only new thing here is that the condition is the complement of a set. So it's just not a set, but it's the complement of a set. But there is nothing different here. So we apply the normal definition of conditional probability. So that's equivalent to the number of elements in the set crime victim, intersection, and drug complement, because that's what's different. And then we divide everything by the number of elements in drug complements. And so if you go back to our definition of conditional probability, I have it up here. Probability of A given B, that's equivalent to the probability of, it's equivalent to the number of elements in the intersection A, B, and divided by the number of elements in B. That definition we are applying almost mechanically in this case. But what played the role of B in our general definition here, we have, instead of B, we have drug C. And so we are dividing in the denominator, we have the number of elements in drug complement. Now, how many people are in drug complement? So we have to go back to question B. Just remind ourselves that there were 50 people involved in the drug business that year. And we are told from question A that there were a total of 5,000 people in Orange Beach, Alabama. So we are basically subtracting 50 people from the there is a mistake here, so it should be 5,000. So we are subtracting 50 people from the 5,000 people, and this is gonna give us 5,950. That's so these are the number of elements in drug C, in drug complement. Now, how many people are in the set crime victim intersection drug C? So this is the set that consists of all crime victims that are not in the drug business. And we were told from question B that it turns out that year that of the 100 violent crimes, 5 happened to the people in the drug business. And so it means that the remaining 95 happened to people not in the drug business. So we basically need to subtract 5 people, which is the people involved in the drug business who were victim of a violent crime, and we find out 95. And this is the set of crime victims who were not in the drug business. That's the intersection. In order to be in this set, you need to be both a crime victim but not being involved in the drug business. And there were 95, according to the data given by the exercise, there were 95 such people. And so now we have all the data, we can just do our division. We do 95 divided by 5,950, and we find out that roughly the chance of being a victim of a crime in that case is 1.9%. And so what's interesting here, because part of the question was also, so if we go back to question C here, part of the question was also who is more at the risk of being a crime victim. Well, if you remember, the probability of Aristeo being the victim of a crime was 10%, whereas the probability of Avital, who's not in the drug business, of being a victim of the crime was 1.9%. So it's significantly higher, the risk or the probability of being the victim of the crime significantly higher for Aristeo, who is in the drug business, compared to Avital, who is not in the drug business.